Electrical equipment must be installed in a neat and workmanlike manner as per NEC 110.3b. This means the installation should be done in a way that is both aesthetically pleasing and functionally sound. It should not appear haphazard or unprofessional. Electrical equipment should not be installed in locations where exposed to excessive temperature, as per NEC 110.26a on. Excessive temperature can degrade the equipment's performance and lifespan, and potentially lead to safety hazards. Installations shall not be made in unsafe locations, as per NEC 110.16a. This encompasses a variety of factors, including but not limited to the presence of flammable materials, corrosive atmospheres, and physical hazards. An enclosure that does not extend beyond the end of the insulated wires shall be considered as not providing protection from arcing faults, as per NEC 408.35. This means the enclosure should fully contain any potential arcing faults to prevent them from spreading. Overcurrent devices shall be readily accessible, as per NEC 240.24 cone. This is crucial for safety, as it allows for quick and easy access to shut off power in case of an emergency. Panels and breakers are typically rated for specific ambient temperature ranges. This rating indicates the maximum and minimum temperatures at which the equipment can operate safely and effectively. It is important to refer to the manufacturer's specifications for the particular equipment used, as temperature ratings can vary depending on the manufacturer and model. Prolonged exposure to high temperatures can damage the equipment, leading to potential hazards such as electrical fires. High temperatures can cause the insulation on wires to degrade, leading to short circuits. High temperatures can also cause breakers to trip prematurely or fail to trip when needed. Additionally, high temperatures can also affect the overall performance and lifespan of the electrical equipment. In the specific scenario described, with an attic temperature potentially reaching 140 degrees Fahrenheit or more, it is likely that standard panels and breakers are not suitable. It's crucial to verify the manufacturer's temperature ratings for the specific equipment to ensure they are appropriate for the environment. There are several other factors to consider when installing electrical equipment in a hot attic. Firstly, ventilation. Proper ventilation can help to reduce the ambient temperature in the attic. This can be achieved through the installation of vents or fans. Secondly, insulation. Insulation can help to reduce the amount of heat that enters the attic from the outside. This can be achieved through the installation of insulation in the attic floor or roof. Thirdly, shading. Shading can help to reduce the amount of direct sunlight that enters the attic. This can be achieved through the installation of trees or awnings. Also, dereting conductors is very important. When conductors are installed in high-temperature environments, their opacity must be derated to account for the increased heat. This means that the conductors will be able to carry less current than they would in a cooler environment. NEC Table 310.15b2 provides adjustment factors for ambient temperature. Also, using high-temperature rated conductors is very important. Conductors with higher temperature ratings such as THHN or XHHW should be used in high-temperature environments. These conductors are designed to withstand higher temperatures without degrading. Additionally, using appropriately sized conductors is very important. Conductors must be sized appropriately for the load they will be carrying, taking into account the ambient temperature and any other applicable factors. Finally, consider using an NEMA 3R enclosure. If the subpanel is exposed to moisture, a NEMA 3R enclosure should be used to protect the equipment from the elements. Also, consider the working space. Ensure that there is sufficient working space around the subpanel to allow for safe and easy access for maintenance and repairs, as per NEC 110.26a. Regarding the installation of the subpanel itself, mounting it directly to a tuxfar with only 2 nails is generally not considered a secure or workmanlike manner of installation. The panel should be securely mounted to a solid surface using appropriate hardware. In summary, installing an electrical panel in a hot attic requires careful consideration of several factors, including temperature ratings, ventilation, insulation, conductor dereting, and proper installation techniques. Failure to address these factors can lead to safety hazards and code violations. Always consult with a qualified electrician to ensure that the installation is safe and code compliant. It is crucial to prioritize safety and adhere to the National Electrical Code (NEC) guidelines when installing electrical equipment, especially in challenging environments like attics with high ambient temperatures. Ignoring these guidelines can lead to dangerous situations, equipment failure, and potential legal repercussions. Let's delve deeper into the NEC sections and their implications for this specific scenario. NEC 110.3b requires that electrical equipment be installed in a neat and workmanlike manner. This seemingly simple statement encompasses several important considerations. Firstly, the installation should be visually appealing and demonstrate a level of skill and attention to detail. Wires should be neatly organized and secured, and the equipment should be properly aligned and mounted. Secondly, the installation should be functionally sound and ensure the safe and reliable operation of the electrical system. Connections should be tight and secure, and the equipment should be properly grounded. In the attic scenario, simply nailing the subpanel to tuxfer with 2 nails is unlikely to meet the requirements of NEC 110.3b. A more appropriate installation would involve securely mounting the panel to a solid surface using appropriate hardware, ensuring that the panel is level and properly supported. NEC 110.26 prohibits the installation of electrical equipment in locations where it is exposed to excessive temperatures. This requirement is crucial for preventing equipment failure and ensuring safety. Excessive temperatures can cause the insulation on wires to degrade, leading to short circuits and potential electrical fires. Excessive temperatures can also cause breakers to trip prematurely or fail to trip when needed, compromising the protection of the electrical system. In the attic scenario, where temperatures can reach 140 degrees Fahrenheit or more, it is highly likely that standard electrical panels and breakers are not suitable. The manufacturer's specifications for the equipment should be carefully reviewed to determine the maximum allowable ambient temperature. If the attic temperature exceeds the equipment's rating, alternative solutions should be considered, such as improving ventilation or relocating the panel to a cooler location. NEC 110.16 mandates that installations not be made in unsafe locations. This requirement encompasses a wide range of potential hazards, including but not limited to the presence of flammable materials, corrosive atmospheres, and physical hazards. In the attic scenario, the high temperatures themselves can be considered an unsafe condition, as they can contribute to equipment failure and potential electrical fires. Additionally, the limited working space in the attic can also pose a safety hazard, making it difficult to access and work on the electrical equipment safely. NEC 408.35 addresses the protection of electrical equipment from arcing faults. An arcing fault is a dangerous condition that can occur where electricity jumps from one conductor to another, creating a high-temperature arc. This arc can ignite nearby materials and cause a fire. NEC 408.35 requires that enclosures for electrical equipment provide adequate protection from arcing faults. This means that the enclosure should be designed to contain any potential arcing faults and prevent them from spreading. In the attic scenario, if the subpanel enclosure does not fully enclose the wiring and connections, it may not provide adequate protection from arcing faults. NEC 240.24 code requires that overcurrent devices be readily accessible. Overcurrent devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. In the event of an overcurrent, the overcurrent device will trip, interrupting the flow of electricity and preventing damage to the electrical system. It is crucial that overcurrent devices be readily accessible so that they can be quickly and easily reset in the event of a trip. In the attic scenario, if the subpanel is located in a difficult-to-reach location, such as a crawl space or behind stored items, the overcurrent devices may not be considered readily accessible. In addition to the NEC sections discussed above, there are several other factors to consider when installing electrical equipment in a hot attic. Conductor ampacity must be adjusted for ambient temperature, as per NEC Table 310.15b2. The ampacity of a conductor is the maximum amount of current that it can safely carry. The ampacity of a conductor is affected by the ambient temperature, with high temperatures reducing the ampacity. When conductors are installed in high-temperature environments, their ampacity must be derated to account for the increased heat. Conductors with high temperature ratings, such as THHN or XHHW, should be used in high-temperature environments. These conductors are designed to withstand high temperatures without degrading. The equipment should be listed and labeled for the intended use, as per NEC 110.3a. This means that the equipment should be tested and certified by a recognized testing laboratory, such as Underwriters Laboratories UL, and should be labeled with its intended use and ratings. The equipment should be installed in accordance with the manufacturer's instructions, as per NEC 110.3b. The manufacturer's instructions provide detailed information on how to properly install and operate the equipment. It is important to follow these instructions carefully to ensure the safe and reliable operation of the equipment. In summary, installing an electrical panel in a hot attic requires careful consideration of several factors, including NEC requirements, temperature ratings, conductor ampacity, and equipment listing and labeling. Failure to address these factors can lead to safety hazards and code violations. Always consult with a qualified electrician to ensure that the installation is safe and code compliant. Remember, electrical work can be dangerous. It is always best to consult with a qualified electrician before attempting any electrical work yourself. They have the knowledge, skills, and experience to ensure that the work is done safely and in accordance with all applicable codes and regulations. Taking the time to consult with a professional can save you time, money, and potentially your life. The NEC is a comprehensive set of standards designed to ensure the safety of electrical installations. Adhering to the NEC is essential for protecting people and property from electrical hazards. When working with electricity, always prioritize safety. Wear appropriate personal protective equipment, such as gloves and safety glasses, and follow all safety procedures. If you are not comfortable working with electricity, do not attempt to do so. Consult with a qualified electrician. Continuous education and training are vital for staying up to date with the latest electrical codes and technologies. Participate in workshops, seminars, and online courses to enhance your knowledge and skills. Staying informed helps ensure safe and compliant electrical practices. When selecting electrical equipment, consider factors such as voltage, current, temperature rating, and environmental conditions. Choosing the right equipment for the application is crucial for safety and performance. Always verify that the equipment is properly listed and labeled. Before starting any electrical work, always de-energize the circuit and verify that it is dead using a reliable voltage tester. This step is essential for preventing electrical shock. Never assume that a circuit is de-energized, always test it to be sure. Maintain a safe working environment by keeping the work area clean and free of clutter. Ensure adequate lighting and ventilation. A well-organized workspace reduces the risk of accidents. Regularly inspect electrical systems for signs of wear, damage, or overheating. Promptly address any issues to prevent potential hazards. Routine maintenance helps ensure the long-term safety and reliability of electrical installations. Document all electrical work performed, including details such as wiring diagrams, equipment specifications, and inspection results. Proper documentation provides a valuable record for future reference and troubleshooting. Always obtain the necessary permits and inspections for electrical work. Compliance with local regulations helps ensure that the installation meets safety standards. Cooperate with inspectors and address any concerns they may have. When working with electricity, always exercise caution and common sense. Avoid taking unnecessary risks and prioritize safety above all else. A responsible approach to electrical work helps prevent accidents and ensures a safe environment for everyone. The information provided is for general guidance only and should not be considered a substitute for professional advice. Consult with a qualified electrician for specific guidance on electrical installations and safety.